Hello?
Hello, David.
Yeah.
Right. Yeah, just want to make sure, just little intro, and to make sure that everyone can listen, very well. Yeah.
Yeah.
Okay. So, Patrick, what did you ask, David?
I was just asking, did David do level 4 as well?
No, he's also doing, level 4 in parallel.
Oh, right, okay. I didn't realise you could do it like that.
Yeah. So, it's good. And David, do you want to ask anything from Patrick? Hello.
Yeah.
So I think there is a little, delay in your reply. Is it, David? Do you notice, Patrick? There is a little bit delay.
Yeah. I hear your
Yeah.
voice like metallic.
Sorry. David, can you confirm that you receive the voice, yeah, and instantly, and you are able to reply, so that I should make sure our session should be fully interactive. Instead, you have any problem of connection or anything else.
Yeah, no, I can hear you now. It was metallic before.
Okay, that's fine. Yeah. So, Patrick, I think you're connected
Better, yes.
at the moment.
Yeah, I can hear, yeah.
Yeah, yours and my communication, is very good. And I believe David is also, able to communicate instantly now. Yeah.
Yeah.
Okay, good. So, like I, explained earlier, that Patrick has completed level 4 and with us, and obviously David is doing, level 4 and level 5, in parallel now. Yeah. Good.
Okay, yeah.
Good. So both you guys are working very well in, IT. I know Patrick, and I also did have a look on the, David's, CV, and I'm very pleased to see, his lots of certifications in various, uh, courses, and especially the like MCSE and CCNA and networking, everything, and he's doing very well. And that's really, good achievement indeed, David. So let me little bit introduce, to David myself. Like I have done, PhD in computing, as well as, I did my master's in computer science. And it used to be the time of, the certifications. Like in 2002, I myself did the certification in Java, Sun certification. Yeah. So obviously the certifications and the demand in the industry is, one side, and the literary, the educationally, like degrees in, higher degrees, like masters, MPhil, PhDs, they are really, considered like academically, but definitely, they are required for the higher levels, what I believe, isn't it, David?
Yeah. Yeah.
Yeah. So I welcome you, both of you, to join this course again, and especially Patrick, and you are,
Yep.
you are starting now. So
Yeah.
I hope, you should have, induction done as well. Yeah.
Yeah, this is my first thing on level 5, yeah.
Yeah. Okay, good. And so let us start now. And obviously, after having, the today's session, Patrick is very well, aware that how we, proceed with the sessions and discussion and anything, needs to be covered up. And obviously, the assessment of this course is basically the assignment based. Like some of the, degrees, they are being examined like in the examination, like they are assessed on the examination, and like these awarding bodies, they want to assess you based on the assignments. Yeah.
Yeah.
So so the major focus will be on, that how you write your assignment, and obviously that needs to be assessed. And then, if there is any, suggestion or referral or, an improvement, you will be given a feedback, time to time. And I wanted to say sorry, you sent email 2 times, but I was, away from the, internet. I was out, and I told Raman that, yeah. So, but definitely he replied to you, yeah?
Yeah.
Yeah.
Thank you.
Yeah, and even, I was expecting that we will meet each other first time, in the in this session.
Yeah.
And after this, I will be able to give you full support, yeah?
Yeah.
Okay, no worries. So don't worry, you will be given a full support. And obviously it's a learning time. It starts now, yeah? And the way you need to start it, once you will be on the way, and then you will not have any difficulty, and you would learn that how you need to achieve the goals, yeah?
Mm-hmm.
Okay, good. So now let us, start from the slides, as well as little bit introduction to the unit. And the unit is, the database design and development, yeah? I believe that in level 4, Patrick, you must have done the relational database basis unit.
Yes. Yeah, it was a long time ago, but yeah, I did that one.
Yeah. And obviously, there are many things, would be similar with the level 4 relational databases, and obviously this one is the database design and development. So, but like these are 2 levels, different levels, so there would be little bit advanced, and the assignment requirements would be a bit higher than the, level 4, yeah?
Yeah.
How about David? You must have done the databases as well.
Yeah, I'm doing it now. Yeah.
Good. And have you done any course or certification into the databases as well?
Yeah, I don't have any certification database, but I work with them, so yeah, I know them.
Okay, so you have done work on the database. Which database?
Mostly SQL Server, Microsoft.
Okay, good. Yeah. So you should have already lots of concept into the databases as well. Yeah.
Yeah.
That's good. Yeah. So obviously, this qualification is a kind of academic. Yeah. And we need to, follow the unit specification. Yeah. Maybe, especially for David. Yeah. Maybe you might be thinking that, you know everything into the unit. Yeah. But obviously you need a patience, and, if you know anything, then, I will, be going through the session smoothly. If you wanted me to ask if you want to ask anything, then I would, go further into detail. But at least as a standard, session, we will go through normally, so that, like a Patrick, or the unit requirement and the delivery should be, carried out in a smooth way. Yeah, you understand?
Yep.
Okay, good. So the unit specification is in front of you. Do you have access to this unit specification on the Moodle?
Yeah.
Yeah.
Yeah. So normally, each unit specification, they describe the aim and the level and, indicative contents and each learning outcome and assessment criteria, against each. Yeah. So, David, I believe that you should be able to understand, this unit specification, and obviously this needs to be covered into the sessions, and then, after the delivery of the unit, and obviously in parallel, you should be able to start your assignment work as well. Yeah.
Yep.
Okay, good. So, learning outcome 1, understand database management system. Yeah. So, normally database management systems, they are, the indicative contents that we need to cover, like organizational structures, data elements, dataset forms, reports, design, like entities, relationships, attributes, keys, data types, normalization, then connectivity of the databases using drivers and these things that we will be discussing in today's session. Yeah. So obviously, these things, are, if you are, you have already been doing databases and you already know, for example, and like, Patrick, he did some of the, relational databases, but we will, revise these things into this, session as well. Yeah.
Okay.
Right. So, now, David, if you don't mind, can I ask the difference between the database and the database management system?
Sorry, say again. I missed the word.
The difference between the database and the database management system.
Yeah, database system is a software to manage database. Database is a collection of data.
Right, Patrick?
Yeah.
What do you want to say about the difference?
Oh, yeah. Okay. Yeah. So, a database is a collection of data which is organized into tables, and the database management system is kind of like the software that you use to manage it all and retrieve the data.
Right. Yeah. That's correct to say. Normally, we interchange these terms. Most of the time, when we need to use the database management system, we say this is a database, and sometimes, we assume that the database itself is a database management system, isn't it?
Yeah.
Yeah. But actually, if we start from the data, then let's say our definition of the data is a collection of facts and figures. But when we collect them to make it an information, then it becomes a database. Yeah. And literally, we can call, if it is a database into the papers, for example, there is no any software. Yeah. But still you can call it, it's a database if you have data in the form of, maybe in papers or whatsoever in form. Yeah.
Yeah.
But when it comes to the database management system, yeah, then it's a system software basically. Yeah.
Okay. Yeah.
Can you confirm the font? You are able to see the font, well, very well.
Yeah, it's fine. Yeah.
Okay, good. Yeah. So normally, database collection of information, which is organized, could be assessed, managed, updated, while database management system is a system software for creating and managing databases. Database management system provides the users and programmers with a systematic way to create, retrieve, update, manage things. So like data collection of data, and like a database management system has got, the complete system, like internal architecture, internally stored on the, drives, and then bridge in order to communicate with the applications, other database management systems, users, and the front end. So it gives a complete a kind of framework in order to manipulate the data. Yeah, I think that's very simple, but just I wanted to go through one by one. Yeah.
Yeah.
Okay. So then next topic is the organizational structure. So again, it's a system that consists of explicit and implicit institutional rules and policies designed to outline how various work roles and responsibilities are delegated, controlled, and coordinated. More specifically, structure describes how members are accepted, how leadership is chosen, and how decisions are made. Yeah. So simply, I believe that you should be very well aware with the organization structure, isn't it?
Yeah.
Yep.
But obviously, you should be able to look, the organizational structure regarding the database perspective, isn't it?
Okay. Yeah.
Yep.
Yeah. So simply, if there is a boss, then under the boss there are worker 1, worker 2, worker 1-to-1, worker 1-to-2. Yeah. So
Yeah.
that's naming convention. Then, if you want to store the organizational structure data, yeah, then obviously the same structure could also be stored into the database. Yeah, like you created a table, then you allocated the person ID 1, 2, 3, 4, 5, and then probably their names boss, worker 1, worker 2, and worker 1, worker under, and then another worker under worker 1. Make sense?
Yeah.
Right. Then now we talk about the data elements. Yeah, basically, David, you should I'm following the sequence of these indicative contents. Yeah, because the unit specifications, they are wants these indicative contents to be discussed uh, during these sessions. Yeah, so is that should be clear to you? Yeah. Okay. Right. So data element, there's a fundamental structure in the data processing system. Any unit of data defined for processing is a data element. For example, account number, account name, address, and city. So basically, that data element is the defined by size, type. Yeah, you must have dealt with any data element. This is like when we say in computing like bit and byte. Yeah, so the data element is the smallest unit which we deal into the databases. Yeah.
Yeah.
Good. So for example, product description is a data field, product number is a data field. So these are the data elements. Yeah, very simple definitions. Yeah, we have to go through and to make it clear. Obviously, if you know, then it's good, and if you don't know, then we can proceed with these obviously definitions one by one. Yeah.
Yeah.
Good. Data set. Yeah, you can write as a simple separate or together as a collection of data. Yeah, most commonly a data set corresponds to the concept of a single database table. Yeah, if anything is in front of you into a table, then you can say it's a data set where every column of the table represents a particular variable. So like a case, age, description, and production length, these things are basically the variables. Yeah, and each row is basically the data set. Okay. like, rows, they make up, to a given member of the data set. Yeah, is that clear?
Yeah.
So rows, the member of the data set, and a variable is the column. So overall, anything within the table, yeah, and it looks like a data set. Basically, these terminologies, yeah, have been, explicitly asked to be discussed. That's why, we are going through. Maybe these are, these terms may not be, needed everywhere, but we have to go through. Is it okay, David? Yeah.
Yeah, that's fine.
Yeah. Then forms, you must be very well, aware with the forms, isn't it?
Yeah.
Yeah. So previously, when
Yeah.
there, it was a time when people used to write the softwares into DOS-based, environments. Yeah. And the DOS-based environments, and then, even, for example, have you ever get a chance to write the queries, SQL queries, and retrieve the data on, let's say, command prompt?
Yeah.
Yeah.
Yeah, like we
Yeah.
write, SQL queries, and we see the, on a prompt, the command prompt, isn't it? What I mean?
Yeah. Yeah, I
Yeah.
know what you mean. Yeah.
And even, for example, if we talk about the data into the data sheet, then this is not, a output into the form, but it is a kind of, a tabular form, and, the non-form based output. Yeah. However, if you really wanted the data into the form type, then they are called the forms. Basically, they are used to entering, modifying data into the database, and that's the very basic, thing we use into the database applications. Yeah.
Okay. Yeah.
Report, and report is offers you the ability to present your data in print. If you have ever received a computer printout of a class schedule or a printed invoice of a purchase, you have seen a database report. Yeah. So normally, what happens when you generate any printout from the database, then it's called a report. Simple. Yeah. Like these
Yeah.
are the yeah. Any question, David?
No.
Good.
Not so far.
Just terminology. These are the terminologies, that when you're trying to describe these, things into, database, terminologies, then reports are those things which, uh, generated for the printer purpose. Yeah. And obviously, there's a very core thing, for every database to get the printouts, on demand, and you can design, reports like, in Microsoft Access. Yeah. When you create a database, and then it allows you to generate the reports, isn't it?
Mm-hmm.
Yeah. Now, we are focusing on the design now. Yeah. So both of you must be aware that designing implementation is different thing. Yeah.
Yeah.
Designing and implementation is different thing. So initially the focus is given on this, topic is the design. If you really want to design a database, then you need to look at the entities. The term entity is any object in the system that we want to model and store information about. Yeah. So
Yeah.
like, this is a kind of, have you heard about the system analysis and design? You must have heard.
Yeah.
Yeah. David, do you have any, idea? You should have.
Yeah.
Yeah. So in the system analysis and design, and obviously there are, lots of certifications as well, object-oriented analysis and design patterns. Have you ever got a chance to work on it?
Yeah, with some, yes.
Yeah, in the, design patterns as well, yeah?
Mm-hmm.
Like, MVC, model view controller, and, there are lots of patterns, isn't it? Yeah? So, the common sense, like, the nouns, most of the time, yeah, or, like in the system analysis and design, what we advise that if you want to create the entities, then, select the nouns, they would become the clauses, and anything else, any actions would be the verbs. If you have a paragraph in front of you, yeah, the description of the, some project or assignment, then the nouns, you understand noun, yeah? So noun should be the entities and the verbs would be the use cases. Similarly, the entities exist in 4 kinds, like a people, things, events, and locations. Yeah. So these things would be extracted as an entity, because you're going to design the system, and how you would be extracting the entities, like by looking at, if it is a people, then you pick up as an entity. If it is a thing, then, and if it is an event or location, then they would become entity. Is that clear, David?
Yeah, yeah.
Good. Everything you could want to put into a database fits into one of these categories. If the information you want to include does not fit into these categories, then it's probably not an entity, but a property of an entity that's called an attribute. Make sense?
Okay. Yeah.
Yeah. Now, so, for example, if we look at, any shop, then customers, products, shops, vendors, and sales, they would become the entities. Yeah. Is that clear?
Yeah.
David?
Yes.
Yeah, because customers would be the certain names and the products would be the things. Yeah. Vendors and sales, and sales is an event. Let's say, for example, a shop is a location. Yeah. Sale is an event. Yeah. And the product is a thing. So by looking at these, definitions, you need to extract the entities. Yeah. So sometime, yeah, why these techniques have been, taught? Because for being a database designer, we need to look at, to hunt the things. Make sense? You want to hit those important things which should not be missed out. Yeah. These are just, the definitions of, for example, an entity and how you would be identifying an entity. Is that clear? Yeah.
Yeah.
Yes.
Okay. Now, obviously, the entities are linked with each other. Yeah. Entities are linked with each other. Yeah. So that's called the relationship in between. Yeah.
Okay. Yeah.
What is that? It's a situation that exists between relational database tables through a foreign key. A foreign key is a column or combination of columns that is used to establish and enforce a link between the data and in 2 tables. Following diagram contains 3 tables. Now, I want to ask you that, have you ever tried the the relationship in between tables, or have you ever got a chance to look at any relationship in between the tables?
Of course.
Yeah. So let us see that how these relationships are defined. Do you know the types of, David, do you know the types of the relationships?
Yeah.
Can you
One
name
one
those?
to many, many to many.
Yeah. Good. Yeah. So basically these are also called the cardinalities. Yeah. So let us go on to the, now if we have a look on these three tables, then students, enrollment, and course. Yeah. So obviously one course could be enrolled many times, yeah, into the enrollment table. Yeah. And then one student could be enrolled many times into the enrollment. Yeah. So that's the reason behind, in order to introduce the relationships. Yeah.
Mm-hmm.
Okay, good. Now one to many relationship. One to many relationship is the most common type of relationship. Like I explained earlier, that one course could be enrolled many times. Yeah. And one student could be enrolled many times. So that is the a kind of situation when you define a relationship. Is that clear?
Yeah.
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 So when, if it is not clear, then we can discuss more. Otherwise, because there are lots of topics, and the we have to cover into the ideas into today's session. Yeah. So obviously, if anything needs a more discussion, then you can let me know now. Otherwise, you can research furthermore on a self study as well. Yeah. While this thing is very obvious and simple, I believe, isn't it? Should I proceed further?
Yeah, sure.
Okay, good. Then many to many relationship. Yeah. In many to many relationship, a row in a table can have many matching rows in table B. Yeah. And vice versa. Like for example, the more interesting thing, that if you want to create a relationship between the student and the course, is it possible to create a relationship between the student and the course?
If you add some foreign keys, yes.
If you have a table, yeah, if you have a table of student and if you have a table of course, yeah, then is it possible you could create a relationship, the many to many relationship in between?
Yeah.
How?
Well, you need to add the course ID to the student table and vice versa, and then you can link them.
No, I mean, what I want to say, that you cannot create, the student and the course many to many relationship without introducing a third table. Did you get it?
You could.
Sorry?
You could if you add the foreign keys in each other table.
Yeah, but normally
Yeah, normally
the many,
normally you don't. Yeah.
yeah, normally we don't. And the way, in order to make it a more meaningful, yeah, obviously it would make a kind of spaghetti, and the relation should be become very more complex. While if you create a third table, which is a junction table, whose primary key consists of a foreign key for both tables, and then the relationship would exist well, right?
Yeah.
Good. So we need a third table as well, like enrollment or whatsoever, but these are the conventions, yeah, they are used, right?
Yeah.
Okay, good.
I agree. Yeah.
Patrick, you are okay with this as well?
Yeah, it's fine. Yeah.
Good. And one-to-one relationship. Yeah. So one-to-one relationship is again, practically that does not exist. So in one-to-one relationship, a row in a table A can have no more than one matching row in a table B and vice versa. Yeah. And there is no basically, benefit of creating a one-to-one relationship if both columns are primary and have unique constants. Yeah. So in a one-to-one relationship, the primary key X additionally is a foreign key and there is no separate foreign key column for each other. So this type of relationship is not common because most information related in this way would be all in one table. Make sense?
Yeah.
When we use the one-to-one, divide a table with many columns, isolate part of a table for security reason, store data that is short-lived and could be easily deleted by simply deleting a table, store information that applies only to a subset of a main table. So one-to-one is basically the obviously we don't need every time, yeah, but when we really want to split one table due to these reasons like divide the columns and due to security reason hiding some information, otherwise it does not have any usage of primary key and foreign key in order to uh, store and manipulate data from more than one tables. Make sense?
Yes.
Yeah, Patrick?
Yeah.
So if we recall again, then at most of the places one-to-many relationships exist, like one student could be enrolling many times and one course could be enrolled by students many times, and many to many is created introducing the third table, and one-to-one probably may not be needed. But if you want to split the course, for example itself, it has got attributes, yeah, then probably you need to divide and keep the things separate, but it would not give an advantage of like when we create the things and we separate the things in order for the efficient efficient retrieval of the data. Now the question arises, why we create these relationships? So that we could reduce the redundancy in the database. Yeah. Normally, our next topic is basically the normalization. Yeah. So in order to produce a good database design, yeah, your tables should be normalized in a sense that you should not be wasting the memory and processing efforts. Is that clear, David?
Yeah.
Yeah?
Yes, it is.
Good. And then, in order to consider the normalization, we create the relationships, accordingly. Yeah, and we try to, follow the suggestions which the normalization processes do. I believe that you should definitely have the idea of the normalization. Probably
Yes.
Patrick, yeah?
Yeah, I remember that, yeah.
So, now after a few slides, there is, the normalization, but now let me complete this, couple of slides, which is about the attribute. So, attribute, yeah, is basically the characteristic of an entity. What is attribute? The characteristic of an entity, we discussed an entity earlier, Yeah, like entity is a customer, the phone number, the customer name, address. These are the attributes. Very simple. Yeah. Good.
Yeah.
Now the primary key. Yeah. What happens? We are now going into the detail and the depth. Yeah. That if we want to process the tables very well, then the keys, the primary key are introduced. It's introduced. The keys are introduced. Which are the keys? For example, primary key, secondary key, or foreign key. A primary key is a field in a table which uniquely identifies each row or record in a database table. They must contain unique values. Primary key column cannot have a null values. I believe you should definitely be aware with the benefits of the primary key, isn't it?
Yeah.
Yes.
Yeah, good. Foreign key. A foreign key is used to link the two tables. You normally define primary key in one table and a foreign key into the another table. Then the relationship between two tables matches the primary key in one of the tables with a foreign key. So after defining the primary key and the secondary key, you should be able to create a joint query. Yeah. For example, if you want to show the specific attributes from one table and specific attributes from another table to make a customized view of your table.
Yeah.
Why that's a one kind of one purpose. That for example, let me give you another example. In table 1 you have 10 attributes, like every time let's say customer information is name, date of birth, address, phone number, many things. Yeah. And you have another customer information related with like order details. Every time you will not need the all customer details, do you? You don't need
No.
customer details. So what happens? You would be saving, these customer details and order details separately. Yeah. And at some time when we really need only specific data from somewhere, from some table, then you create a query. Yeah. That select, let's say, customer ID from customer. Yeah. Where it meets with the customer ID of another table, like from the orders, and your particular columns would be selected with using a kind of table name dot qualifier of the column name. Have you ever created such query into the SQL?
Join the table?
Yeah, in order to create a primary key, foreign key, query.
Yeah.
Yeah. So that's the concept behind usage of major concept and major use, that we define primary keys and foreign key in order to store the data first and then apply the queries on those tables. Yeah.
Okay.
Good. Let me give you another example. For example, by mistake, for example, customer IDs, the customer attributes are customer ID, last, customer, last name, first name, street, these things. Yeah. If it was a poor design, then order table could also hold these, additional customer information stored, replicated into the order table as well. Is it possible?
Sorry,
Like,
say again the question. I didn't hear.
sorry?
I didn't hear the question, sorry.
Yeah, let me repeat it. I mean, for example, if you are a new student, if you are new into the database, yeah, then people, what they do, they store the customer information, whole customer information into the customer table, as well as they would be repeating the customer information into the order table as well. Yeah, and it happens, yeah. That is basically called the redundancy of the data. Yeah. So if, for example, if there is no any primary key or foreign key in between the customer and the order table, then how you would be getting the address of the customer? For example, a customer came to you and you registered the customer, you noted down, the address as well. It's a big, address, for example. And when you are going to place an order, yeah, in order to dispatch the order, will you require the customer address?
Yeah.
Yeah. And then obviously, if you are not able to create a connection in between the customer and the order, then you would be repeating you would need to repeat the customer address into the order table as well. Make sense?
Yeah.
Yes.
Yeah. But using the beautification of the foreign key and primary key, you only define the one customer ID as a primary key, and the same customer ID is a foreign key in the other table. And whenever you require the address, then you would be writing a query that, in addition to order number and order date, give me the customer ID as well. How you would be saying that print, for example, select or print customer last name as well. Yeah. So you can easily access, you can create a view without redundancy of the data. That is basically the designing of the database, which helps you to create these things more, in good way. Yeah, that's the purpose behind. Make sense?
Yeah.
Okay, good.
Yeah.
Now the data types, simply, uh, there are lots of different data types. Few are standardized. One second. Sorry, Okay. So you must be very well, aware from the data types. Yeah. Hello.
Hello. Yeah.
Yeah.
Data types. Would you like to say anything about the data type?
I can't remember what a float is.
It's like a number, like a decimal number.
Okay.
Like, is a data type is basically the characteristic of the data, that in which form that needs to be, in simple words. If it is a character, yeah, it's a vacha, yeah. These are name given to the character types, and obviously the length varies. And if it is a text, it's a float, like as a decimal number, it's a double, and integer. So depending on your need of the data type and range, a kind of memory slot is being allocated into the database. Simple. Make sense?
Yeah. If you use the wrong one as well, the performance can be impacted, can't it? You can have performance problems.
Yeah, not a definitely. That would be misusing the resources. Yeah.
Yeah. Yeah.
For example, if you needed a kind of text type data, and probably if it is taking like a 256, for example, bytes, yeah, and then you're required to, you're just using its 5%, yeah, maybe only name. Then even if you don't use it, but by default the blank spaces would have been used and occupied into the memory. Yeah.
Yeah.
So that's a problem basically. Now normalization. Yeah. Next topic is the normalization. Normalization is a technique of organizing the data in the database. Now, by looking at the previous problems and discussions, yeah, what we were facing, we were duplicating the data, that is redundancy, yeah, and we could face another problem as well. So let us see what is a normalization. Is a technique of organizing the data in a database. Like in previous example, I gave you an example. If you were not organizing and creating the tables very well, then you were overriding and overburdening the database, isn't it?
Yeah.
Yeah. So you need to normalize the database, yeah, like to refine the database. So normalization is a systematic approach of decomposing tables to eliminate data redundancy and undesirable characteristics like insertion, update, and deletion anomalies. Yeah. So what are these anomalies? For example, if you have not organized the database, then you can face these anomalies. One is the insert anomaly. This refers to the situation when it is impossible to insert certain types of data into the database. For example, if you did not define any, let's say, decimal number, yeah, and decimal number, and you wanted to store the decimal number into the integer, yeah, then there could be a problem. If that particular type could not be fixed into the character, the length or type, it could be a problem. So anything which does not let you to insert the data is basically the insert anomaly. Delete anomaly. Deletion of a data leads to unintended loss of additional data that we had wished to preserve. Yeah. Sometimes you created the, if you take the example of the customer and the order, yeah, you temporarily wanted to delete the, let's say, address from the order, for example, but possibly you could delete the data from the customer details registration. Yeah, it could happen. Have you ever heard about it, or have you ever faced the accidental delete of the data?
Yeah.
Yeah. So that is the delete anomaly. Then there is then there is the update anomaly. This refers to the situation where updating the values of column leads to a database inconsistencies. For example, if you purchase something and you should have been invoice from the accounts department, and the accounts table could not be updated. Yeah, it happens sometimes, and so that is the update anomaly. Like if you had a customer detail, it was saved into one record, but at somewhere by mistake the order was sent to the old address. Yeah. So you can, most of the time into companies, you excuse for oh sorry, your details were not updated fully. That was the problem, isn't it, David?
Yeah.
Yeah. So insertion anomaly, deletion anomaly, update anomaly, that happens most of the time. Let me see how many slides left. the important topic is, the discussion about the normal forms, first, second, and normal form. Then there is, the ODBC and JDBC. Yeah. Just one thing, you will not be rushing, to stay for maybe 5-10 minutes, extra tonight.
Yeah, that's fine.
Yeah. About David?
Yeah, okay for me.
Okay, that's fine.
Okay for me.
Okay, good. Yeah, because, it was today's the first session, and I was wanted to make sure, that we could hear and we could introduce each other. Yeah, well, and that's good. Yeah, let me try to finish as soon as possible. So, if the things are not normalized, yeah, then they lead to these anomalies. Yeah, and what I would say, like unexpected errors that you do not expect, but they happen and you never know that why they are happening. Obviously, you would know later on, but not during the process. Okay, so rules, normalization rules. Normally, we use at a standard level: first normal form, second normal form, third normal form, and but like a fourth normal form, B, C, and F, and these things are used at the very enterprise level. But today we will discuss 3 of them. So let us see the first normal form. This table, can you have a look on this? Is there any problem into this table?
Yeah, it's got in the color.
Sorry to interrupt. Yeah, you have studied in the relational database as well. David, you definitely should be aware with this one as well.
Yeah, yes, I'm saying like 2 tables in one, probably a flash issue. Yes, like the price is redundant, for example.
Sorry, your voice is breaking, but can you say again? Hello?
Can't hear you.
Yeah, can you repeat, please?
Really?
Hello? Hello? Hi, Patrick?
No?
Hi, yeah, I'm still here.
Yeah. Hi. Can you, I think for a few seconds the connection was lost, or our communication was, discontinued. So, what did you say about this, David?
Yeah, I can see the tables, yes.
Okay, so let me go through. The table is in the first normal form. It means you have tried to optimize it if it is satisfied the following condition: contains only atomic values. There are no repeating groups. So atomic values, like in this example,